George here again, and we are back again working with this animatronic game. We had done some sort of outliney holographic shader in the last video, and now we are probably going to need to make it so that a piece that is empty in a given assembly level is going to automatically craft this model with this material attached to it when necessary. So to do that, I'm guessing we're going to jump down into the animatronic assembly manager, and each assembly level, now if we go into this assembly level script, I believe each assembly level, if I remember correctly, knows what the required pieces are, which get populated at runtime by the pieces themselves through the assembly manager. Yeah, we iterate through all the pieces, then we add the associated assembly level that piece has, its piece basically. So then when we go through all of the different pieces that get added, we need to grab the mesh filter for that object, create a new rendering representation for it for this layer, and work from there. Compositor is not available. Let's ignore Steam VR for the moment. And we also need to know the material that we're going to be working with. So let's do a few things here. Let's do serialize field material, and we'll just call this, what do we call it? Hologram or assembly, missing assembly. What do we call this again? Animatronic part outline. Animatronic part outline. Now also, the snap points know, no, it's just easier to do it with an assembly level, because the assembly level will turn on all the correct pieces and turn them off as necessary. So when a snap occurs here, I'll know what to do. Okay, so then we need to create and store for each one of these assembly pieces the holographic portion of its mesh. I guess the easiest thing to do right now is just to make a list of game objects and just call these, let's make that lowercase. There we go. Animatronic part outline. And as we add, there we go. And as we add assembly pieces, we'll also add them here. At least we will be at some point once we get all the logic down. So what do we need to do? We need to create this new game object. So let's just do game object temp is going to be equal to a new game object. Then we're going to do temp dot add component. We're going to need a mesh renderer. Then temp dot add component and a mesh filter. Okay, let's store these away really fast. Let's just do MR and mesh filter MF. And of course, we're going to add temp to our list. Before we do that, we want to grab the assembly pieces mesh filter and copy that mesh over for our new one. So let's do mf.mesh. Now it says shared mesh. Let's just use the mesh for now. I know the shared mesh is used in the editor. mf.mesh is going to be equal to, let's see, piece dot game dot get component. Now this might be a problem if I have sub pieces dot mesh. Now this is a little lazy too. I should probably be storing that out and doing a check to make sure it actually exists first. So mesh filter piece mesh filter is going to be equal to this grab right here. And then if we have that, so if piece mesh filter is not null, we have something to work with. Then we're going to add a holographic layer to it. Actually, this should be mesh, shouldn't it? No, this should be mesh filter. Then we're going to, if piece mesh filter, mf.mesh is going to be equal to piece mesh filter dot mesh. We also need to set up the mesh renderer. So mesh renderer dot material is going to be equal to the material we specify in animatronic part outline material. There we go. With that, it looks like we should have copied over everything. Now we just need to make sure that when a snap occurs, we turn off that object, that game object. And actually this game object should be made as a child of this object as well, just for easy record keeping. At least that's what I'm gonna do. So let's do a temp.transform.parent is equal to this.transform. Let's give ourselves a note here about what the heck we're doing. Pulling out assembly piece info, not pulling out, how about making a holographic outline of the piece that needs attaching. Okay, now that we have that finished, we have our animatronic part outlines here. We get an assembly snap occurred notice, and we receive the assembly piece. And with that information, we should be able to know, since these two arrays are going to match up, the required pieces for completion and the animatronic part outlines array, we can now deactivate them accordingly. So here we iterate over all required pieces for completion. If the required piece for completion is equal to the one that we've done, then we set that one to be placed. We should also turn off the associated hologram with that piece. So we'll do animatronic part outlines. We'll also use I, and then we're going to do dot set active and do false for now. We could also delete that, but for right now it's probably better. We haven't considered taking the parts off again. If we wanted to, for some reason, reorder things, might as well just leave it generic enough to kind of allow that functionality in the future, rather than actually delete the thing. If this one is not placed, then all finished is equal to false. If all finished, well, this should have taken care of making sure the holograms are turned off anyway, so I don't need to worry about doing anything there. This is going to go through and turn off any of the assembly snap points, and then this is going to unlock the next assembly levels. Now, when the unlocking of assembly levels occurs, which is in here, we need to turn on the holographic elements. They should technically be off for that layer, because right now, add assembly piece is going to turn everything on. Therefore, we need temp dot set active to be false. We don't want it to be running at this time and rendering. What we do want is for our animatronic part outlines to become activated upon a call to unlock assembly level. So for each var ASP and assembly snap points to fill, we iterate over this. Let's just do another loop. For each var temp in animatronic part outlines, temp dot set active is going to be true. And that should activate that for us. And since unlock assembly level, my mouse is not working. Because unlock assembly level gets called by assembly manager at the very beginning, it should be good to go. Let's close out of that. Here we are. Let's kill this object now, left the copy of the foot. We still need to go into Maya and fix the pivots on the feet, since they're still in the center of the world instead of with respect to where they should be. Now let's go over here to all the assembly levels, make sure they have the material associated with them. So there we are. And let's hit run. Now if I go over to scene, we'll notice that we only have 2 holographic elements, and that's the current assembly level that needs to be unlocked, indicating that these feet need to be placed at those locations. So this is a start of a success, so great. All right, so I'm gonna, let's see, I will make this a shorter video, make it so that these things aren't so long. So that worked. We will, in the following video, probably jump into Maya and fix these feet. And we'll need to do a test. And unfortunately, I really don't want to break out the VR system at the moment. It's just a pain in the butt sometimes to work with. So I'll see if there's some way that I can do more work without actually needing to test in VR. But anyway, I will see you all next time. So long, and good day, good night, good evening, good morning it looks like. Ooh, new year. Happy New Year's to everyone, 2019. So long, and goodbye.